Okay, so for our first example, we're going to find the area of the region enclosed by these two curves, y equals e to the x and y equals x, from x equals 0 to x equals 1. So the first thing that we always want to do is graph these curves in order to see what this region looks like. And first we'll do y equals e to the x. That we'll put in red, right? It just looks like this, right? It crosses the y-axis at y equals 1. And then our curve y equals x we'll do in blue is just the diagonal line y equals x. I know that's not perfect. I can make that a little bit better. Okay, so this is y equals x, right? And we're going to just take the region bounded by these two curves and between x equals 0 and x equals 1, we'll say somewhere over here. Right, so it's going to be this region here, right, inside of these two curves. And you see that we have this top function and this bottom function. And the way that we compute this area and the way that was just described in the slides is first, approximating by these rectangles of width, so maybe this is xi, right, of width delta x, and height will be this yt minus yb, right, where yt stands for y top and yb stands for y bottom, right, so top and bottom functions. And so our area is just going to be the integral from a to b of yt minus yb, integrating with respect to x, right? Because really this, if you want to think about the definition, is just coming from, summing up the areas of these rectangles. The width delta x becomes this dx, and yt minus yb is the height of the rectangle, right? So this is just like height times width of a rectangle, and then summing up those areas. Okay, so we already mentioned that it's pretty easy to see in this case that yt is equal to e to the x and yb is equal to just x. So our area is going to be this integral from here. We know, because it's given to us, that we're integrating from 0 to 1, right? So so area is equal to the integral from 0 to 1 of e to the x minus x, right? And so we should hopefully know what the integral of e to the x is. That's one of the reasons why e to the x is such a special function, is its integral is just e to the x, right? I'm omitting the constant of integration. And then to integrate x, we're just using our power rule for integrals, right? So this is just going to be x to the n plus 1 over n plus 1, right? As long as n is not equal to negative 1. And here n, if we're looking at this part here, right, if we're looking at just this part here, right, the n in this case is just 1, right? So we have this is equal to e to the x minus x to the 1 plus 1 over 1 plus 1, so squared over 2, from 0 to 1, right? And so this is equal to e to the 1 minus 1 squared over 2 minus e to the 0 minus 0 squared over 2. Don't forget those parentheses there. In this case, I guess it doesn't matter, but because this is just 0. We have e minus 1/2 minus e to the 0 is equal to 1, right? Any constant, non-zero constant, a to the 0 is just going to be equal to 1. That's just one of our exponential rules, right? I guess I'll box these two. These are just kind of laws that we have, right? So this is minus the quantity 1 minus 0. So that's what I was saying when, it is always important to make sure to have these parentheses written here. In this case, it didn't matter because the distribution was on a 0 anyways, but we have e minus 1/2 minus 1, which is just e minus 3/2. And that's our area, right? Note is, we know that area is always positive in the real world, right? Area is always positive. So a little sanity check is that when you're done with your calculation, whatever you get should be positive. Even if it's positive, right, you may still have made a mistake, but if it's negative, you definitely made a mistake. And most likely what happened if you got a negative area is that you switched the rules of top and bottom function up there. So just be aware of that. It's just a little sanity check. Here we have e minus 3/2. E is approximately 2.7, 3/2 is 1.5, so this is definitely positive. So that's our answer.